The Atlantic Ocean is the most traveled body of water in human history. For 500 years, every ship that carried colonizers, soldiers, slaves, explorers, and immigrants between the Old World and the New crossed it. Every transatlantic cable that connected Europe to America runs beneath it. Every piece of cargo, every passenger, every signal that crossed between two hemispheres passed over it. The Atlantic is not mysterious. The Atlantic is familiar. It is the ocean we think we know. And that is exactly the problem. Because beneath the surface of the most watched, most crossed, most studied ocean on Earth, there are things that do not fit. Things that have been found and not explained. Things that are happening right now and that our best models cannot account for. Not one thing, 5 things, each one stranger than the last, each one pointing to the same conclusion. We do not know the Atlantic the way we think we do. What we are going to do in this documentary is go through all 5, not quickly, not as a list. We are going to go deep into each one, the way this channel always does, because the details are where the real strangeness lives. And by the time we reach the end, the Atlantic Ocean, the one right outside the window of every city on 2 continents, the one you have seen in photographs 1,000 times, is going to mean something very different to you than it does right now. We are only at the beginning of this one, and where it goes is genuinely unexpected. If this kind of story is what you came for, there is a new one every week on this channel. Now, let us go in. Mystery 1. The Lost City. In the year 2000, a team of scientists from the University of Washington was conducting a research dive in the Atlantic Ocean. They were exploring the Mid-Atlantic Ridge, the underwater mountain range that runs the entire length of the Atlantic from the Arctic to the Antarctic, marking the boundary where the tectonic plates of the Americas pull slowly away from the plates of Europe and Africa. New seafloor is being born there at the rate of a few centimeters per year. The Earth is literally growing. They were not looking for anything unusual. They were mapping geology, routine science, and then, at a depth of approximately 800 meters, on a feature called the Atlantis Massif, they found something that nobody had any framework for understanding. Towers, white, vast, rising from the seafloor like the spires of a city in the dark. Not rock, not basalt, not the iron-black volcanic material that typifies the seafloor. These structures were made of carbonate, pale and almost luminous under the lights of the remotely operated vehicle. Some of them barely larger than a toadstool, and one of them standing 60 meters tall. 60 meters, nearly 200 feet, a single structure built from nothing but chemistry, rising out of the absolute darkness of the deep Atlantic. They called it the Lost City, and the name stuck because nothing else seemed adequate. Here is what makes the Lost City genuinely strange, and why it is not just a remarkable geological formation, but something that changes how we think about life itself. Hydrothermal vents are not a new discovery. Scientists found the first ones in 1977 near the Galapagos. They form at volcanic sites where seawater seeps into cracks in the seafloor, is superheated by magma below, and rises back out carrying dissolved minerals that precipitate into chimneys in the cold, deep water. These black smoke vents are hot, acidic, and rich in iron and sulfur, and they host ecosystems powered entirely by chemical energy rather than sunlight. Chemosynthesis, life without the sun. When scientists found them, it expanded what we thought life could do. It suggested that life might exist in places we had never considered. It changed the boundary conditions. The lost city is not that. It is something else entirely. There is no magma beneath the lost city. It is not volcanically active. The towers are not made of iron sulfides. They are made of calcium carbonate, and they are formed by a chemical reaction between seawater and a type of rock called peridotite, rock that normally lives deep in the Earth's mantle and only rarely surfaces. When seawater contacts peridotite, a process called serpentinization occurs. The rock is chemically transformed, heat is released, and in the process, hydrogen and methane are produced continuously, without any biological input, without any sunlight, driven purely by the interaction of two natural materials. The towers of the lost city have been growing for at least 30,000 years. Some estimates put them at 120,000 years or more. They existed before modern humans left Africa. They have been standing in the dark Atlantic, producing heat and gas, hosting their strange communities of microorganisms, long before there was anyone to find them. And the chemistry they produce is not just unusual. It is, according to some of the scientists who have studied the site most closely, the kind of chemistry that might have produced life in the first place. The hydrocarbons generated by the lost city's serpentinization process are produced at 10 to 100 times the rate seen at typical black smoker vents. The environment is alkaline rather than acidic. The temperatures are warm but not extreme. It is, in a sense, a more hospitable version of the conditions that many origin of life researchers believe provided the first chemical ingredients for biology. When scientists talk about where life might exist beyond Earth, on the icy moons of Jupiter and Saturn, on Europa or Enceladus, where liquid water moves beneath a frozen crust, they talk about serpentinization. They talk about the kind of chemistry the lost city produces. And they are right, because the lost city is the closest thing on this planet to what we imagine an alien ocean might look like. In 2024, a team of researchers drilled into the seafloor beneath the lost city and extracted a core sample of mantle rock 1,268 meters long, a world record. They are hoping the minerals preserved in that rock can tell them something about the conditions under which life first emerged on Earth billions of years ago. Think about that. The answer to the question of how life began on this planet might be sitting in the rock beneath a field of white towers in the Atlantic Ocean, discovered 25 years ago, still not fully understood, still producing heat and hydrogen in the dark. We found something on the floor of the Atlantic that we do not have a full explanation for, and what we have found might be the most important place on Earth. Mystery 2. The current that runs the world. This one is invisible. You cannot see it. You cannot dive into it and watch it move. But it is the largest thing happening in the Atlantic Ocean right now. And what is happening to it is something scientists have spent years arguing about and are still not finished arguing about. It is called the AMOC, the Atlantic Meridional Overturning Circulation, and it is a system of ocean currents that, if you had to describe it simply, functions as the planet's heat pump. Here is how it works. In the tropics, the Atlantic is warm. Surface water absorbs heat from the sun, and the currents carry that warm water north up toward Europe, releasing heat into the atmosphere along the way. This is why London, which is at the same latitude as parts of Canada that routinely see minus 30 degrees in winter, has a climate mild enough to grow palm trees. The heat from the tropical Atlantic is being delivered there continuously by moving water. Without the AMOC, large parts of Northern Europe would be dramatically colder, permanently. When the warm surface water reaches the North Atlantic, it has released enough heat to become cooler and denser. Cold, dense water sinks. It sinks deep into the lower layers of the ocean and then flows south, carrying the cold water back toward the tropics at depth. When it reaches the tropics, it warms again, rises, and the cycle continues. An enormous conveyor belt of water, moving heat from one part of the planet to another, operating continuously, driven by the simple physics of temperature and density. The AMOC does not just regulate European climate, it influences weather patterns across the entire Northern Hemisphere. It affects rainfall in Africa. It affects hurricane formation in the Atlantic. It affects sea level on the eastern coast of the United States. If the AMOC weakens significantly, the effects are not just regional, they are global. And here is the part that is difficult to sit with. For more than 100 years, there has been a patch of cold water south of Greenland that has not warmed the way the rest of the Atlantic has warmed. Everything around it gets warmer. The global average temperature rises, but this patch stays cold and sometimes even gets colder. Scientists noticed it decades ago and could not explain it. It is now referred to as the cold blob, and it is sitting there in the data, anomalous and persistent. A study published in 2025 finally connected the cold blob to something larger. The researchers showed that the only climate models that could reproduce the cold blob were models in which the AMOC was weakening, in which the Great Conveyor Belt was slowing down. The cold blob is what a weakening AMOC looks like from above the surface. It is not a mystery in isolation, it is a symptom. The AMOC is likely at its weakest point in at least 1,000 years. This is not a fringe claim. It is the conclusion of multiple independent research groups using different methods, different data sets, and different models, and it keeps emerging from the data. And now for the part where scientists disagree, because this is not a simple story. Some researchers argue that the weakening is gradual and manageable, that the AMOC will not collapse this century, that the changes will be significant but not catastrophic. A study published in Nature Geoscience in 2025 found that the AMOC might experience a weakening of 18 to 43% by the year 2100 under the most severe scenarios. Significant, but not collapse. Other researchers argue that the system is approaching a tipping point, a threshold beyond which the weakening becomes self-reinforcing and the circulation shuts down abruptly. In October 2024, 44 climate scientists published an open letter arguing that the risk of AMOC collapse has been greatly underestimated and that it could happen within decades. A preprint study published in January 2026 using high-resolution modeling found that the AMOC may be more sensitive to freshwater inputs from melting Greenland ice than previous models captured. Both positions are held by serious scientists using real data. The disagreement is not about whether the AMOC is weakening. That part is agreed upon. The disagreement is about what happens next, how fast, how far, whether there is a threshold, and what is on the other side of it. Here is what the data shows and what we do not know. We know the AMOC is weaker than it was a century ago. We know that freshwater from melting ice in Greenland and the Arctic is one of the factors driving that weakening, because freshwater is less dense than salt water and disrupts the sinking mechanism that drives the circulation. We know that the cold blob south of Greenland is consistent with this picture, and has been there for at least a century. What we do not know is whether there is a tipping point, whether the system can restabilize if warming slows, whether the models we have are capturing the full complexity of what is happening in the deep water. The AMOC operates over timescales that make it extremely difficult to study. The relevant processes happen over decades, not years. Our direct observational record of the AMOC's strength is only about 20 years long. We are trying to understand something that operates over centuries using 20 years of data. The Atlantic is not just a body of water, it is a machine. A climate machine that has been running for millions of years, regulating heat across half the planet. And that machine is changing in ways that the people who study it most closely are still debating, in ways that do not have a clear resolution. That is not a comfortable fact to hold, but it is an honest one. Mystery 3. The sea with no shore. Here is a body of water that does not behave like anything else on Earth. The Sargasso Sea has no coastline, no shores, no land borders of any kind. It is a region of the North Atlantic Ocean bounded entirely by other ocean currents. The Gulf Stream to its west, the North Atlantic Current to its north, the Canary Current to its east, the North Atlantic Equatorial Current to its south. 4 moving walls of water enclosing a roughly oval region, approximately 1,000 miles wide, sitting in the Atlantic like a still eye at the center of a spinning system. And in that still water, something grows, sargassum, a type of brown macroalgae that does something no other seaweed does anywhere else on Earth. It floats, not attached to anything, not rooted to a reef or to the seafloor. It lives its entire life cycle on the surface of the open ocean, drifting in the still water of the Sargasso Sea, reproducing vegetatively, producing more of itself without ever touching land or seafloor. The ecosystem that has built itself around the sargassum is unlike anything else on the planet. The sargassum fish, a creature that looks exactly like a piece of floating weed and would be impossible to identify as an animal if it were not moving. The sargassum shrimp evolved to be the precise yellow-brown color of the algae it hides in. The sargassum pipefish, the sargassum nudibranch, dozens of species that exist nowhere else on Earth, that evolved specifically to live on this floating raft in the middle of the Atlantic, that have nowhere else to go. If the Sargasso Sea disappeared, they would disappear with it. The current boundaries of the Sargasso Sea should not hold. By every model of Atlantic Ocean circulation, the currents that surround it should slowly erode the edges of the system, carrying the sargassum away, thinning it, dispersing it across the ocean. The fact that it persists, that it has persisted for millennia, suggests that there is something about the dynamics of this region that our models are not capturing, something that keeps the system stable in a way that is not fully explained. And then there is the sand beneath it. Researchers analyzing sediment from the seafloor of the Sargasso Sea found something unexpected in the composition of the material. A significant portion of the seafloor was made of the fossilized remains of shallow water organisms, creatures that belong in tropical reef systems, creatures that belong in coastal shallows, not in the middle of the open Atlantic at depth, not in a region that has been deep open ocean for millions of years. How did they get there? The explanations that have been posed involve transport by currents from distant reef systems, or ancient shifts in sea level that left reef material behind when the water rose. But none of the proposed explanations fully accounts for the volume and the type of material found. The Sargasso Sea is sitting on top of a seafloor that contains a record of something we have not reconstructed, a history of this part of the Atlantic that we have not read. And then the sargassum started expanding. Something has changed. In recent years, sargassum blooms have been growing beyond the boundaries of the Sargasso Sea, reaching the Caribbean, washing onto the beaches of Florida and Mexico, reaching the coast of West Africa. In 2018, the bloom was large enough to be seen from space. It stretched from the coast of Africa to the Gulf of Mexico. Tens of millions of tons of algae rotting on beaches, closing harbors, collapsing local fishing industries across the Caribbean. Why? The honest answer is that scientists are not sure. Changing ocean currents, climate change, increased nutrient runoff from the Amazon, all of these may be contributing. But the scale of the recent blooms exceeds what any single factor can account for. Something about the Atlantic has shifted in a way that is releasing the Sargasso Sea from whatever equilibrium was holding it in place. And we do not know what that something is. The sea with no shores has always been strange. Now it is moving. Mystery 4. The blue holes. Now we go somewhere very specific and very dark. A blue hole is an underwater sinkhole, a circular shaft dropping vertically into the seafloor or into a shallow reef, formed during the last ice age when sea levels were lower and the limestone of the seafloor was exposed to rainfall, which dissolved it, forming cave systems and sinkholes. When the ice age ended and sea levels rose, these sinkholes were flooded. They became blue holes, columns of water sealed off from the surrounding ocean by their geometry, by the depth of their opening, by the chemistry of the water inside them. They look, from above, like blue circles in a lighter blue sea. Perfect, almost artificial, almost like something was placed there deliberately. Some of them are hundreds of meters across. Some of them descend hundreds of meters into the earth. The Atlantic has more of them than any other ocean on the planet. The Bahamas alone has hundreds. The coast of Belize, the Gulf of Mexico, the Caribbean. Blue holes everywhere. Most of them have never been dived. Most of them have never been sampled. Most of them have never been mapped in detail. They sit there, open, waiting, a few dozen meters below the surface, in some of the most visited tourist waters in the Atlantic. And we have barely looked inside them. Here is what we have found when we did look. At a certain depth inside most blue holes, the oxygen runs out. The water below a certain point becomes anoxic, dead to everything that requires oxygen to live. This is because the geometry of the hole prevents the exchange of water with the surrounding ocean. The deep water cannot circulate. The oxygen is consumed by decomposition at the bottom, and it is not replaced. The boundary between the oxygenated water above and the anoxic water below is often visible as a distinct layer, a shimmering interface where the two chemistries meet, like the boundary between oil and water. In 2023, researchers from Florida Atlantic University sent a remotely operated vehicle into a blue hole off the coast of Florida. The hole had never been explored. At a depth of approximately 100 meters in the completely anoxic layer, inside water that contained no oxygen and measurable levels of hydrogen sulfide, a chemical that is toxic to virtually all multicellular life. They found organisms, not fossils, not traces, living organisms, bacteria, single-celled creatures, surviving in an environment that should be lethal. Not just surviving, metabolizing, reproducing. They were alive in a way that should not be possible according to what we understood about the conditions for life. This is not without precedent. We know that anaerobic organisms, bacteria that do not require oxygen, exist. They are ancient, remnants of the period before Earth had an atmosphere rich in oxygen, living in sediments and deep geological formations. But the density of life found in these blue hole anoxic layers and the variety of chemistry they are producing is still not fully characterized. We do not know what else is in those holes. We have only looked inside a small number of them. But here is the part that I find most difficult to articulate simply, because it is not just about unusual bacteria. The water at the bottom of some blue holes has not mixed with the rest of the Atlantic since before the pyramids were built. In some cases, since the last ice age. That water is a closed system. It has its own chemistry, its own temperature, its own record of conditions that existed in the Atlantic thousands of years ago. It is an archive, a sealed chamber that has been sitting there, unread, in waters that thousands of tourists snorkel over every year. When researchers have been able to sample and analyze this ancient water, they have found chemical signatures of a different Earth, of different atmospheric composition, different ocean temperatures, different carbon cycles. They are reading the diary of the Atlantic from 10,000 years ago, written in the chemistry of water that nobody has disturbed since it was sealed inside the rock. And we have only read a fraction of those diaries. There are hundreds of blue holes in the Bahamas, hundreds of sealed chambers, each one a separate archive, each one containing its own record of Atlantic history, its own potentially unique chemistry, its own possibly unique organisms. Every time a team has sent a camera into a blue hole they have never explored, they have found something that was not in any database. Something that did not fit the existing picture. Not occasionally, every single time. The pattern is clear. The Atlantic floor in this region is perforated with openings into a world that is both literally below us and genuinely unknown to us. Each one is a separate question. Most of them have not been asked yet. Mystery 5. The mountain range. Nobody knows. The longest mountain range on Earth is not the Himalayas. It is not the Andes. It is not the Rockies. It is a range that almost nobody has ever seen, that does not appear in any geography class, that has no famous peaks, no famous climbers, no famous anything. It runs the entire length of the Atlantic Ocean, from Iceland in the north to the waters off Antarctica in the south, through the Indian Ocean, through the Pacific. 65,000 kilometers of mountain range. Continuous. The longest geological feature on the surface of the planet. It is called the Mid-Ocean Ridge, and the Atlantic portion of it, the Mid-Atlantic Ridge, runs directly through the middle of the ocean. It marks the place where two tectonic plates are pulling apart, where new seafloor is being born, where the Atlantic is, very slowly, growing wider. You know where it is, in a sense, even if you have never heard of it. Iceland sits directly on the Mid-Atlantic Ridge. The island exists because the ridge pushed enough rock above the surface of the sea to form land. Iceland is a piece of the seafloor that broke through, the only place on Earth where you can walk on the Mid-Atlantic Ridge above water. And yet Iceland is the exception. The rest of the ridge, 64,000 kilometers of it, is below the surface. Some of it below 3,000 meters of water. Most of it has never been seen by any human eye. Some of it has been mapped by sonar. Most of it has not been mapped in high resolution. We know it exists. We know its rough shape. We know it is generating new seafloor at a rate of a few centimeters per year. Beyond that, most of it is a black box. Here is what makes the Mid-Atlantic Ridge genuinely strange as an object of knowledge. We are more familiar with the surfaces of other planets than we are with this mountain range. The volcanic peaks along the ridge, some of them as large as any volcanic mountain on the surface of the Earth, are erupting. Right now, somewhere along those 65,000 kilometers, rock is coming up from below the Earth's crust and meeting cold seawater. New seafloor is being made, lava is flowing, hydrothermal systems are forming and collapsing. The geology of the planet is active there, continuously, and we have almost no direct observations of it. In recent years, sonar surveys have revealed that the ridge is not a simple chain of mountains. It has valleys. Deep rift valleys at its center, where the two plates pull apart, some of them several kilometers wide. It has transform faults, places where the ridge is offset laterally by fracture zones that cut across it. It has entire mountain ranges within the mountain range, subsidiary ridges and plateaus that have never been named, never been surveyed in detail, never been studied. The Lost City, which we talked about at the beginning of this documentary, is sitting on the Atlantis Massif, a feature of the Mid-Atlantic Ridge. The serpentinization chemistry that creates it is possible there because the ridge has brought mantle rock unusually close to the surface. The ridge created the conditions for the Lost City. The ridge may have created the conditions for life on Earth, and we have only seen a small fraction of it. Here is the scale of what we do not know. There are almost certainly more hydrothermal systems along the Mid-Atlantic Ridge that we have not found. There are almost certainly more ecosystems like the one at the Lost City, or unlike the one at the Lost City, in ways we cannot predict because we have not looked. The ridge is an active geological system 65,000 kilometers long, and we have detailed imagery of perhaps a few hundred kilometers of it. We are aware of the existence of a mountain range that dwarfs anything on land, and we have essentially not explored it. The Atlantic is growing right now. The floor beneath the ocean is moving. New rock is being born in the darkness of the rift valleys. Somewhere along the ridge, a volcanic event is occurring that no instrument is recording. A hydrothermal vent is forming that no one will find for years or decades. An ecosystem is beginning to build itself around a source of chemical energy that has just become available in a place that has never been seen. This is not science fiction. This is what the planet does, continuously, in the dark. Closing. What the Atlantic is. Let me bring all of this together. In the darkness of the Atlantic sea floor, there is a field of white towers that has been producing heat and hydrogen for 120,000 years, that operates through chemistry we do not fully understand, that may be showing us what the origin of life looked like. The water above it carries a current system that regulates the climate of the northern hemisphere, and that is weakening in ways that 44 climate scientists have called drastically underestimated. At the surface, a sea with no shores is expanding beyond its boundaries for reasons that no single factor can account for. Beneath the shallow waters of the Bahamas, hundreds of sealed chambers contain ancient water that has not moved since before civilization began, and organisms that should not be alive by any model we have. And running through the middle of all of it, from the Arctic to the Antarctic, is the longest mountain range on Earth, almost entirely unseen, actively generating new seafloor at this moment, almost certainly containing things we have not found. Not one of these is a ghost story. Not one of these requires anything supernatural. Not one of these is a fringe claim from the edges of science. They are all sitting in peer-reviewed papers in the data of NOAA and the University of Washington and 44 climate scientists and the research teams who go into blue holes and come out with water samples that do not match the existing models. They are all in the same ocean, the familiar one, the one in every atlas, the one that billions of people live within sight of, the one that has been crossed more than any other body of water in human history. Here is the image I want to leave you with. Right now, as you hear this, there is a blue hole in the Bahamas that no human being has ever entered. The water at its bottom has not moved since before the first Egyptian pyramid was built. There may be chemistry in that water we have never measured. There may be organisms in that water that have never been seen. They are alive in there. They have been alive in there. They were alive in there before there was anyone to find them, and they will be alive in there long after this conversation has ended. We do not know what they are, because we have not looked. The Atlantic is not the ocean we thought we had figured out. It is not the familiar crossing between two worlds. It is an active, changing, hiding, reducing, still mostly unknown thing. It is doing something to the climate that we're watching happen in real time and still arguing about. It is growing new rock in the dark. It is preserving water from another age of the earth in sealed chambers beneath shallow seas. It is sustaining life in places life should not be able to sustain. The surface of the Atlantic is not the Atlantic. It never was. That is the thing about this ocean, about any ocean. The part you can see from a beach or from a ship or from a satellite image is the least interesting part, the least strange, the least informative about what the ocean actually is. Everything that is genuinely remarkable about the Atlantic is underneath, in the dark, in the cold, in the pressure, in the water that never sees the sun and never has. We have been crossing the Atlantic for 500 years. We have been studying it for decades. We have named it, mapped it, measured it, crossed it 10,000 times. And the 5 things we talked about today are all things that we do not fully understand, not because we have not tried, because the ocean is very deep and very dark and very patient. It is not going anywhere. Neither is what it is hiding. Every week, Abyss Files goes somewhere the surface does not show you. There's a new story like this one waiting, and I promise you, the deeper we go, the stranger it gets.